Hello everyone and welcome to our video on solving linear systems using the substitution method. For question number 1, we are going to look at a linear system with these equations. So we're going to have y equals 4x plus 3 and y equals 2x plus 9. And with the substitution method, so again, when we're trying to solve a system, the idea is that there should be, or we're hoping that there is some sort of intersection point between these two lines. Now, with a system, there's 3 possible types of solutions. We have one solution, so we have an xy coordinate point that is sort of the intersection point of these two lines. We could have infinite solutions where we have 2 lines that are the exact same line, or we have no solutions where the slopes of the 2 equations are the same. But all of the problems that we're going to do today have just one solution. So in this problem, the idea is that we're trying to solve for, we're trying to substitute one equation into the other so that we can solve for a single variable. And then we'll take whatever that answer is and plug it back into our other equation at the end. So what I noticed in this first problem is that both of these equations have y equals. So we have y equals 4x plus 3 and y equals 2x plus 9. Well, if y is equal to both of these things, then it would make sense that these things must be equal to each other because they both have a value of y. So what I can do, and one way to think about it is just say, well, if y equals this stuff, I can take this stuff and substitute it in where I see y here. So what we'll actually have is we'll have 4x plus 3 equals 2x plus 9. And from there, we start trying to solve this equation. We're trying to get x by itself. So the first thing that I'm going to do, and there's a couple different ways that you could go about this that are going to get you to the same answer. I generally try to get the variables on one side first. So I go ahead and minus 2x on both sides. That gets rid of the 2x over here. 4x minus 2x is 2x plus 3 equals 9. And then I'm trying to do whatever it takes to get the x piece by itself. So now I'm going to subtract 3 on both sides. And that gives me 2x equals 6. And then, again, I'm trying to get x by itself. Right now, we have a 2 that's being multiplied to x. To undo that 2, we have to do the inverse operation of multiplication, which in this case is division. So we're actually going to divide both sides by 2. And when we do that, we get x equals 3, because 6 divided by 2 is 3. So that's the first part. That's the x part of this coordinate point that will be our solution. Now what I need to do is I need to take this value for x and plug it into one of my original equations. And it doesn't matter which one we choose. You just need to choose one of them. I'll go ahead and just choose the top one. So we'll say then that y equals 4, and instead of the x, I'm going to use my value of 3 because I now know that x is supposed to equal 3 plus 3. And I know that 4 times 3 is actually 12, so here I actually have 12 plus 3. And 12 plus 3 is going to give us 15. So we actually know that y equals 15. So the solution to a problem like this, so the solution to this system is the coordinate point x comma y, which is 3 comma 15 in this case. So this is the point in which these two lines intersect one another. Now, we only tried this when we plugged in this value of x. We only used one of these equations. And what we want to do is we'd like to check our answer to make sure that we did all of this correctly. And one way that we can do that, we can check our work by taking the value of x and the value of y and plugging it into both of these equations and making sure that the equations check out, that the left side and the right side are equal to one another. So we'll do that. So in the first equation, we had y equals 4x plus 3. So instead of y, I'm going to write 15 equals 4x, or 4 times x. So we're going to do 4 times 3 plus 3. We know that 4 times 3 is 12, so we have 15 equals 12 plus 3, We know that 12 plus 3 is equal to 15, so we have 15 equals 15. So we can go ahead and check that off. So we know that solution works for that equation. And what we'll go ahead and do, I'm going to go ahead and write just check over here. So I'm leaving a note to myself. This is where I'm checking my work. And then we'll do the same thing with the other equation. So we go back and we're going to say y equals 2x plus 9. Instead of y, we're going to plug in 15. So we'll say 15 equals 2 times x, but we know that x is 3 plus 9. 2 times 3 is 6. And so on the right side, we have 6 plus 9, and 6 plus 9 is 15. So we have here that 15 equals 15. That is true. And so we've shown that if we take these values for x and y and plug them into the equations, it works. It makes when we get to the end result here on both of these, we get an answer, or we get a solution rather that's true. We get this final equation where we're showing that the left side and the right side are equal. So we know that 315 is the solution to this given system here, which again was these two equations. So now we're going to have you try question 2 on your own. And so what we'll do here is put a little line. And here's question number 2. Again, we're trying to solve this system, and we're going to have y equals negative 7x plus 22, and y equals 2x minus 14. So go ahead and give it a shot. All right, so to solve this problem, again, we're using the same method of substitution. We're going to we know that y equals this stuff and y equals this stuff. So we know that these two quantities must be equal to each other. And so that's essentially saying we can take that if y equals all of this stuff, we're plugging all of that stuff in for y here, or vice versa. And so what we'll end up with is negative 7x plus 22 equals 2x minus 14. And then we start trying to solve this. So again, I'm going to try and get the x's by themselves first. That's just how I do these problems in general. So I'm going to go ahead and add 7x to both sides. That cancels this. And we get 22 equals 2x plus 7x, which is 9x. And then we still have a minus 14. I'm now trying to get the x by itself, so I'm going to try and get rid of this minus 14. So I'm going to do the inverse operation, which is to add 14 on both sides. And when I do that, on the left, I get 36. On the right, I get 9x, and these cancel each other out. So I'm pretty close now. I want to get the x by itself. It's being multiplied by 9, so now I'm going to divide by 9 on both sides. And that gives me that 4 equals x. And that's the same as saying x equals 4. Okay, so I know that x equals 4. And now I'll do the same thing that I did on the last problem, which was to say, now that I know the value of x, I plug that into one of my original equations to get the value of y. This time I'll choose this bottom one. So we'll say that y equals 2x, but again, we know the value of x is actually 4, so 2 times 4 minus 14. We know that 2 times 4 is 8, so 8 minus 14 is negative 6. Negative 6. We know that y is negative 6. So we put that all together, and we're going to go ahead and say that our solution is the coordinate point, again, x comma y, so 4 comma negative 6. Again, that's not enough, though. We need to go ahead and make sure that we check our answers. So I'm going to go ahead and check this here. And so we're going to plug these values into our equation. So the first one was y equals negative 7x plus 22. So I'll say negative 6 equals negative 7 times 4 plus 22. I know that negative 7 times 4 is negative 28 plus 22. And I put the right side numbers together. Negative 28 plus 22 is negative 6. And negative 6 does, in fact, equal negative 6. Okay, then now I'm going to check the second equation. And so we'll say negative 6 equals 2 times. Again, we're going to plug 4 into that. Minus 14. You know that this is 8 minus 14. And we get negative 6 equals 8 minus 14 is negative 6. So that also checks out. So again, we do want to check our work because sometimes we come up with numbers that actually don't work for both equations, and then we haven't solved the system. So that is the first couple of questions. So the first type of these substitution problems that you're going to see for solving linear systems is going to be where you have two equations that have y equals. Okay. So now we're going to go ahead and move to the next type of problem that you will see. So we're going to look at number 3. And question number 3 says, we're going to try and solve this as system. We have y equals 5x, and we have 3x plus y equals 64. So in a problem like this, what we're going to want to do is we want to identify which of these equations has a variable that's already by itself, whether that's x or y. In this case, I noticed that this top equation has y by itself. So what we're going to do is we're going to say, well, if we know that y equals 5x, then we know that we can take this quantity and just replace it here, because again, we know that y is 5x. So this y can just be turned into a 5x. So when we do that, we have 3x plus, this is going to be 5x now, equals 64. 3x plus 5x gives me 8x. So we know that 8x equals 64. And again, we have this 8 multiplied by x. So we want to get rid of this 8. We have to divide it out. So we'll divide by 8 on both sides. And that gives us x equals 64 divided by 8 is 8. So then we get x. And then just like the previous problems, we're going to now take this value of x and plug it into one of our equations. I'm going to go ahead and choose the top equation here. So we're going to say y equals 5, and then we know that x is 8. So I'm going to replace that x with 8. And so we know that y equals 40. What I would like you to do now is to go ahead and check this solution. So our solution here is the coordinate point 8, 40. So I want you to go ahead and check this solution by plugging in the x value and the y value into both of these equations and checking that. And then we'll move on to question number 4. All right, in question number 4, we're doing something similar. In this case, this one's going to be a little more complicated. We're going to have negative 36x plus 2y equals 132. And we're going to have y equals 12x. So the first thing we're going to do is try to identify which one of these equations has a variable that's already on its own. In this case, it's y down here. So I know that y is really the same as 12x. So I'm going to take this 12x and plug it into the y into the other equation. So now that gives us negative 36x plus 2 times y. Y is 12x. So we're going to put parentheses 12x equals 132. We've got to do some multiplication here. We have negative 36x in front plus 2 times 12x is going to be 24x equals 132. Negative 36x plus 24x is the same as negative 12x. So we have negative 12x equals 132. And then we're going to divide both sides by negative 12 on both sides. And when we do that, these cancel here, or reduce down to 1 over 1, which is the same as 1. So we're going to get x equals negative 11. This is negative 11. So that's the first part. All right, and now what we'll do is we'll take that number and plug it back into our equation to solve for y. So we're going to have y equals 12 times x, and x is negative 11. So we're going to get y equals negative 132. So I'm going to just write out for my instructor, whoever's going to look at my work, that I know what the solution is. It's x comma y. So in this case, negative 11 comma negative 132. And we can check our work, right, by plugging in the x value and the y value into our two equations. I'll go ahead and show that once more here. So we'll say negative 36 times negative 11 plus 2 times negative 132 should give me a positive 132. Negative 36 times negative 11 is 396. Plus, this is, actually, it's going to be negative, so I'm going to just go ahead and say minus. You can say plus, negative, but we're going to prefer that you say minus here. So we'll say minus 264 equals 132. And if you plug this in your calculator, you do get that 396 minus 264 is 132. And we know that 132 equals 132. Okay, so this is our check. So nice. Then we need to check our other equation. So on the bottom, we see the second equation was y equals 12x. So we know that y is negative 132. So we're going to say negative 132 equals 12 times x, which is negative 11. 12 times negative 11 is negative 132. And so we have negative 32 equals negative 132. And again, we're just checking to see that if we plug in those numbers on the left side and the right side of the equations, we should get numbers that match. And we do that twice. So we're good to go. That is our solution. All right, I want to give everyone one more example of these problems really quickly. Because in 3 and 4, I'm only giving you examples where you have y equals and then some number with an x or some number multiplied to x in both of these. I want to show you one where I have a little bit more than that. I'm going to grab a new piece of paper here. And we're going to look at one final question. So question number 5 is going to be y equals 2x plus 1. And then on the other side, we're going to have 5x plus 5y equals 20. So again, the very first step is we're going to identify which one of these equations has a variable that's already by itself. In this case, it's this top one, y equals 2x plus 1. So I'm going to take all of this stuff and I'm going to substitute it in for y in the other equation. So I'm going to end up with 5x plus 5 times 2x plus 1, because I'm plugging, that's what y equals, 2x plus 1. So I'm substituting all of that in, and that is equal to 20. So now what I need to do is notice that I have a number outside of these parentheses. So we have what's called the distributive property. I'm going to take that 5 and multiply that to both of these things here. So we're going to have 5x plus 5 times 2x is 10x, plus 5 times positive 1 is positive 5, and that all equals 20. So we're going to try to combine any like terms we have. We have 5x and 10x that are like terms here, so we're going to combine those. That's going to give us 15x plus 5 equals 20, and then we're just trying to solve, right? So I'm trying to get x by itself. The first thing I'm going to do is get rid of this positive 5, so I'm going to minus 5 on both sides. And that gives me 15x equals 20 minus 5 is 15. I can divide by 15 on both sides. And that's going to give me that x equals 15 over 15 is 1. So we have that x equals 1. And then once we get to that point, we're going to do the same stuff where we plug this value of x in for one of our equations. In this case, I'm going to recommend that we do this top one because it already has y by itself. So we'll say that y equals 2, and then instead of x, we're going to plug in our value that we found for x, which is 1. 2 times 1 is 2. Sorry, 2 times 1 is 2. So we have 2 plus 1, and 2 plus 1 is equal to 3. So our solution for a problem like this is going to be 1, 3, 1, 3. And again, I'm going to suggest that you go through and check this as well. I would always check your solutions to these problems. So for our check, we're going to take the first equation. We know that our value for y was 3, so we'll plug in a 3 into our original equation. So we have 3 equals 2 times 1 plus 1. 2 times 1 is 2, so we have 2 plus 1 on the right side, and 2 plus 1 is 3, so we have 3 equals 3. So that one checks out. We're going to do the same thing for the second equation. Remember, the second equation here is 5x plus 5y equals 20. So we will write 5, and then instead of x, we're going to replace x with a 1. We're going to substitute that 1 in. 5 times 1 plus 5 times y. Y is 3 in this case, equals 20. We know that 5 times 1 is 5, plus 5 times 3 is 15. Does that equal 20? Yes, 5 plus 15 is 20, and 20 does equal 20. And there you have it. You now know how to solve linear systems using the substitution method.